All right, so thanks everybody for being here, and thanks Mario for inviting me. What I'm going to do today is, as the title suggests, is talk about metaphysical indeterminacy, and I'm going to propose a new framework which is an attempt at solving a problem that has shown up in the literature. So this is the roadmap. I will start talking about metaphysical indeterminacy in general, and then I will, in particular, delve into a theory proposed by Elizabeth Barnes and Robin Williams. BW is acronym for Barnes and Williams. That is probably the most discussed theory of metaphysical indeterminacy in the literature. Then I will be talking about a challenge that has been raised, and that is the challenge of deep metaphysical indeterminacy. So apparently there are cases of indeterminacy that cannot be modeled in the Barnes and Williams theory. Then in the third part, I will be proposing my own characterization of metaphysical indeterminacy, which supposedly is not faced with a problem of deep metaphysical indeterminacy. And then at the end, I will be making a few remarks about the logic of metaphysical indeterminacy. All right, so let's get started. When we talk about indeterminacy, well, we talk about something which is very general. There are many different sources of indeterminacy. Indeterminacy could originate in language, for instance. If I say Bob is bald, we could think of it as a case of indeterminacy which originates in language, and that's because the term, the predicate, being bald is indeterminate. So in that case, we talk about semantic indeterminacy, and the natural framework for dealing with the semantic indeterminacy is the supervaluationism of Fine. So according to Fine, to say that Bob is bald is metaphysically indeterminate means that the term being bald has multiple ways of being made precise. And according to some, the sentence is true, and according to others, it's false. So that's when we have semantic indeterminacy. Another possible source of indeterminacy can be the mind. So one could say, for instance, and this is the view which has been defended by Tim Williamson in his epistemicism. So when we say Bob is bald, that sentence is semantically determinate, so it's either true or false. However, the speaker doesn't know whether it is true or false, and the speaker doesn't know that because he or she doesn't know the exact extension of the term bald. Now, these are kinds of indeterminacy which we are not going to be concerned with today. Instead, I'm going to tackle the issue of whether there is some kind of indeterminacy which originates in the world, namely in the non-representational world. So if the world itself is in some sense indeterminate. Until recently, this view was not taken too seriously, and probably the main reason was that there was not a clear characterization of what metaphysical indeterminacy is. Things have changed recently, thanks to Robin Williams and Elizabeth Barnes, who have proposed a characterization of metaphysical indeterminacy in a number of papers. And their characterization has two features. It is a modal characterization, because it makes use of the apparatus of possible worlds, and I'm going to say in a minute exactly how they used it. and also it is precessificational in the sense that it involves the idea of the world as something that can be made precise. Okay. So let's start talking about the modal part of their characterization. And in order to do that, we have to make a very basic distinction. We have to distinguish between worlds and ersatz worlds. So worlds are something like this where we live, something concrete made up of objects and properties. Ersatz worlds are very roughly complete descriptions of worlds. In particular, we're going to think of ersatz worlds as classical, maximally consistent sets of sentences defined in a semantically non-defective language. Let's break that down. So take a language, supposedly a very expressive language, perhaps an infinitary language, which is not semantically defective in the sense that it does not have vacuous terms and it does not have semantically indeterminate terms. Any sets of sentences which is maximally consistent with respect to classical logic is going to be an ersatz world. So again, ersatz words are supposed to be complete descriptions of concrete worlds. All right. Now, this is the model part. Now let's take a look at the precessificational part. So Barnes and Williams give this definition, which is that an ersatz world, E, is said to be a precessification of a world W, just in case E does not determinately misrepresent W. Okay, so another way of saying it roughly is that an ersatz world of W is something which is not determinately false at W. So formally, we can represent that by the condition that every sentence in E is not determinately false at W. And now we can finally give their characterization of metaphysical indeterminacy. So a world W is said to be metaphysically indeterminate just in case it has multiple preclassifications. So the idea is that, say, our world is metaphysically indeterminate when there are at least two complete ersatz worlds, such that neither of them is definitely a misrepresentation of actuality. Okay. One observation is that, which is going to come up later, is that the Barnes and Williams characterization is not a reductive analysis of metaphysical indeterminacy, and the reason is that metaphysical indeterminacy is defined in terms of the preclassification of a world, which is defined in terms of the notion of determinacy. Okay. So this is their theory, and let's take a look at how we can explain a case of metaphysical indeterminacy. So think of set theory. We know that in standard set theory, the continuum hypothesis is indeterminate in the proof theoretic sense, because it cannot be either proved or disproved. And the continuum hypothesis says that the smallest uncountable cardinal is the cardinal of the continuum. And now let's suppose that we have some kind of realist attitude towards mathematical truth, so that the proof theoretic indeterminacy of the continuum hypothesis is mirrored by some indeterminacy in the world. So the set theoretic universe is itself indeterminate. How are we going to model that? Where if we are Barnes and Williams, we're modeling in the following way. There are two ersatz worlds pre-specify actuality. One contains the sentence to the Aleph 0 is Aleph 1, and the other one contains its negation. Okay, so if that is the case, then we have a case of metaphysical indeterminacy in their sense. Now I'm going to turn to the main issue about their theory. And this issue has a name. It's called the objection from deep metaphysical indeterminacy, which has been raised by Brett Scow in a paper of a couple of years ago. And now I'm going to give an argument, a step-by-step argument, but before that, I'm just going to give the very rough idea. And the rough idea is that arguably one of the most interesting cases of metaphysical indeterminacy, which is indeterminacy in the world, is provided by quantum indeterminacy. Okay. So for instance, if a particle has definite momentum, it will not have a definite position. Now, according to their theory, that means that there are ways of making the world precise in which one says, for example, the particle is on the left and the particle is on the right, okay? But also the momentum must be precise. So in every one of these precisification, every property of the particle is precise, and that's precisely what quantum theory says, that it is impossible for all the properties of a particle to be determined at the same time. Therefore, that's the objection. The Barnes and Williams theory cannot account for metaphysics, for quantum indeterminacy. All right. So here is the argument. Suppose we have a world W, it could be our world, with one electron E, which has only two possible momenta, say, for sake of simplification, expressed by the sentences M and M prime, and possible positions expressed by P and P prime. Okay. Now, suppose that E has determinate momentum, could be M. Okay, that's a sentence that represents that expresses the momentum of the particle. It follows that has indeterminate position, and that is by Heisenberg's uncertainty principle. By Barnes and Williams theory, there must be, assuming that this is a case of metaphysical indeterminacy, there are precisification E prime, so these are ersatz worlds, one containing the sentences M and P, and the other one containing the sentences M and P prime. Okay. However, again, quantum theory cannot says that these pairs of sentences cannot both be true, so these ersatz worlds are not ways the world can be made precise. And the conclusion is that the Barnes and Williams theory cannot capture quantum indeterminacy. Okay. So in order to clarify further the argument, I'm going to look at a few replies to this argument and see where they fail. Reply number one, quantum mechanics could be an incomplete theory. So it's a theory that perhaps gives an incomplete account of what happens in a quantum system. That means that even if, according to the theory, position and momentum cannot both be precise, in reality they are precise. So the indeterminacy is just an epistemic rather than metaphysical kind of indeterminacy. And if that's the case, then we would have to come up with some hidden variable theory. For instance, Bohmian mechanics, which is exactly a theory which claims that all these properties can be determined at the same time, even if we cannot know the complete story. The counter reply, which is due to Scow, is this, is that, look, there are different interpretations of what the quantum mechanics says. And there is at least one, which is known as the orthodox or Copenhagen interpretation, according to which the story told by quantum mechanics is a complete representation. And therefore, position and momentum are just not both sharp at the same time. Okay. Now, of course, this interpretation might be false. However, it might also be true. So there is at least a possible world where the Copenhagen interpretation is the correct interpretation. And at that world, the kind of indeterminacy is metaphysical and cannot be accounted by the Barnes and Williams theory. Okay. So since the Barnes and Williams theory supposedly gives an account of metaphysical indeterminacy not just in this world but at everyone, then in general it is inadequate. Second reply, one might think, okay, look, the argument was that there are no ersatz worlds where both position and momentum are defined or determinate, but that is just a physical impossibility, okay? It is a metaphysical impossibility. So it is at least metaphysically possible to have both properties or observable defined at the same time. So those ersatz worlds do exist. And I think this is just wrong, and the reason is that ersatz words are supposed to be complete sets of sentences. If they're complete, they also contain a postulate that says position and momentum cannot both be sharp, and therefore, if there are also sentences that say position is sharp and momentum is sharp, then there is a formal inconsistency, and therefore that is a metaphysical impossibility, and therefore there is no such in ersatz world. Reply 3 is, well, okay, those ersatz words represent impossibility, so let's accept a metaphysics of impossible ersatz worlds, so representation of impossibilities, okay? And so the idea is that if we use those ersatz worlds, so ersatz impossible world, we can model quantum indeterminacy in the Barnes and Williams theory. I think there are at least two reasons why we should be wary of this option. The first one is that, well, ontological parsimony and theoretical conservativity advise us against using such objects unless it's necessary. So the idea is, look, in the literature we find many interesting applications of impossible worlds, but they should be used if we have already shown that we cannot represent certain notions without using them. Okay. And what I'm going to argue in a bit is that indeed there is a way of representing quantum indeterminacy without using ersatz impossible worlds, okay, compatibly with ontological parsimony and conservativity. The second point is a bit more specific. Suppose we do accept ersatz impossible worlds, then we would have to say the following, that the precisifications of a world W will be the ersatz worlds, possible or impossible, that do not determinately misrepresent it. Okay. Now, suppose that the continuum hypothesis is a case of metaphysical indeterminacy, then that means that there is an ersatz world which contains both the sentence 2 to the Aleph 0 is Aleph 1 and its negation. Why is that? Because neither of those sentences definitely misrepresent how things are, okay? But if that's the case, then the theory is not determinately consistent, because a way of making reality precise is a way in which a contradiction is true. But we would like to have a notion of metaphysical indeterminacy that doesn't commit us to something that's strong. So, in other words, we would like to have a notion of metaphysical indeterminacy which is compatible with the idea that contradictions are determinately ruled out. Okay. All right, so we're left with a challenge. So my conclusion is that Scout's argument is sound. We're left with a challenge, and here I quote him: how to model deep metaphysical indeterminacy remains an open question. I'm going to state two theses that I will defend. The first one is this, that for reality to be metaphysically indeterminate is not to be represented by a plurality of not inadequate complete ersatz worlds, which is the Barnes and Williams view, but rather to be represented by one adequate incomplete ersatz world. And the second thesis is that if we do adopt that characterization, the resulting theory will not have a problem of deep metaphysical indeterminacy. So it will be able to model quantum indeterminacy. In order to do that, I will have to argue for a lemma, which is this, that not all ersatz worlds are complete, which is maximally consistent, which is a form of revisionism about model ontology. So what I'm saying is that logical space is not defined exactly by the maximally consistent sets of sentences, but instead there are some ersatz words that are incomplete. Okay. So let's see why that should be the case. Take a world with a particle E, okay? And suppose that that particle has sharp momentum. Now, by the uncertainty principle of Heisenberg, we know that the position is indeterminate. So any ersatz world that represents W is a world where since M, the sentence M for the momentum is in there cannot be any P or P prime that represents a determinate position. Okay? That means, and that's condition one, that it does not have a determinate position. Okay. Now, so far, so good. The problem is this, is that we just said that P and P prime, so the sentences that say, I don't know, the particle is on the left or the particle is on the right, they are not in the ersatz world. Now, if the ersatz worlds are complete, their negations must be in there. Okay. So not P and not P prime are in every preclassification of W. Okay, which means that it does not have a position. Why is that? Because having a position means being here or being there. Okay, more precisely means there is some x such that x is the position value of the particle, which is equivalent with the disjunction of all the sentences that specify that value. Okay. So if each of those disjuncts is false, then the sentence E has a position is false, and so it does not have a position. So clearly, the second condition is stronger than the first. Saying that it does not have a determinate position is not the same as saying it does not have a position simpliciter. Okay. Now, the issue is whether we should only believe in one, which I take to be obvious, or we should also believe in two. And what I'm arguing is that we should only believe in one. Okay, so only the weaker claim. And there are empirical reasons for that. Now I'm going to give an argument, but before that I'm just going to give the rough idea. So it's a quantum mechanical fact, an empirical fact, that two particles can have both indeterminate position, okay, so we don't know where they are, and yet they have a determinate distance. Okay, so they are determinately, say, at one distance, one from the other, even if they, each of them does not have a determinate position. Okay. Now, if being at a distance from something is a spatial relation, then in order to bear that relation to something, you must be in space. And therefore, it cannot be false that you have a position. Okay? Even if it can be true that you do not have a determinate position. So here's the argument. First premise, physical distance is a relation between positions in space or space-time. Second premise, distance between physical objects is physical distance between their positions. It follows from 1 and 2 that physical objects which are at some distance are objects which have a position in space. Okay. Now, the quantum theoretical fact that I just mentioned is that particles in a superposition of positions can be at some distance from each other. So from 3 and 4, it follows that particles in a superposition of positions can have a position. Okay. So the conclusion is that when E is in a superposition of positions, it is true that it does not have a determinate position. That's exactly what it means to be in a superposition of positions. But it is false that it does not have a position, precisely because of the argument that I just showed. Okay. What's the conclusion? Well, the problem was that if we assume that the ersatz words are complete, then it followed that the particle does not have a position. But we say that this is false. Therefore, by modus tollens, we must reject the thesis that the quantum worlds, ersatz worlds, must be complete. Okay, and therefore I conclude that logical space includes incomplete ersatz worlds. All right, so now I'm assuming this logical space with incomplete ersatz worlds, and once we have that, we can take a look at my proposal. I start with this definition about ersatz worlds. So I say that an ersatz world E is said to be adequate for a world W just in case it represents it. What does it mean exactly? It means that the sentences in that ersatz world are exactly those that are true at that world. Okay. And given this definition, I can define metaphysical indeterminacy. So the condition is this: a world W is said to be metaphysically indeterminate just in case it has an incomplete adequate ersatz world. So the idea is that our world, say, is metaphysically indeterminate when the ersatz world which adequately represents it is incomplete. Okay. Now, in order to clarify further this view, I'm going to make a few observations. Notice that Barnes and Williams and I agree on this one thing, that for a world to be determinate, metaphysically indeterminate, it means that it is described by a unique and complete ersatz world. Okay. Now, so obviously, when it is indeterminate, we must deny that there is a unique and complete ersatz world for this world. Okay. So what they do is deny the uniqueness part. So they say that there are multiple ersatz worlds. But we just saw through Skou's argument that if we take that route, then we have an inadequate characterization. So I'm taking the other one. I'm sticking with the uniqueness, and I'm denying the completeness part. Okay, and I can do that because I have incomplete ersatz worlds, which they don't have. Okay. The second observation is that my definition of an adequate ersatz world requires a biconditional. Otherwise, a problem would arise. So if we go back, when I define an adequate ersatz world, here I have it biconditional. Okay, whereas for the analogous notion, Barnes and Williams only use a conditional. And I have to do that because if I only had the conditional from left to right, then suppose that E is an empty ersatz world, then it would be trivially adequate for W, and therefore W would be trivially metaphysically indeterminate. Okay, and since W is any world whatsoever, then metaphysical indeterminacy would be trivially necessary. The third point is that every world has exactly one adequate ersatz world that represents it. So suppose you had two, then by extensionality, there is some sentence P which is in one and not the other. So that means that P would be both true and untrue in actuality, a contradiction. Okay. So there is exactly one ersatz world for each world. Also, the theory I proposed provides a reductive analysis of metaphysical indeterminacy. We can see that, let's go back. Metaphysical indeterminacy is defined in terms of adequate ersatz world, and the definition of an adequate ersatz world does not use the notion of determinacy. Okay, so this is unlike Barnes and Williams' theory, in which the notion of an ersatz world for W does use the notion of indeterminacy. And finally, there is no problem of deep metaphysical indeterminacy. So if E, say, has determinate momentum and indeterminate position, then the adequate ersatz world will be one in which contains M for momentum and neither P or P prime or their negations. Okay. All right, so now I'm going to look at a couple of objections to my view and look at my replies. One is this. Now, quantum mechanics tells us that a particle cannot both have sharp momentum and sharp position at the same time. However, it is possible for a particle to have unsharp momentum and unsharp position at the same time. Okay, so that means that our ersatz world will not contain M and prime and their negations, and it will not contain P, P prime and their negations. Okay, so assuming for sake of simplicity that these are all the propositions we have, atomic propositions, this will be an empty ersatz world. Now the problem is this, is that there are many, in fact infinitely many different states of the particle which have this feature of being both unsharp with respect to position and unsharp with respect to momentum. Okay. In some of them, the position will be a bit sharper and the momentum less sharp. And in other ones, the momentum will be a bit sharper and the position less sharp. Okay. So there are infinitely many. Okay, but it seems that they're all represented by the same ersatz world, the one that doesn't contain any of those atomic sentences. Okay, so if that's the case, then obviously there is a big problem of expressive incompleteness. Okay, there are many possibilities that are all represented by the same ersatz world. And however, there is a way of addressing this issue. Now, it is a quantum mechanical fact that every state of a system, no matter which one, is sharp, has a sharp value with respect to some property. Okay, so for any state, there is a property P such that the system has a certain determinate value X for that property. Okay. If that's the case, then assuming that our word-making language is sufficiently expressive, there will be some atomic sentence that says particle E has property P with value X. Okay, and that will be in the ersatz world that represents the world, the quantum system. Okay, so again, for no matter what the state of the system is, there will be a sentence of that form, which is true, and therefore is going to be in the ersatz world. Okay, so it is not the case that the ersatz world is empty and there are many different possible quantum states that are all represented by the same ersatz world. So as far as I can see, there is no problem of expressive incompleteness. Here's another possible objection that some people have raised, and it's an objection from semantic indeterminacy. So consider a sentence like Vulcan has smaller mass than Mercury. Okay. Now, one might think that that sentence is truth valueless. If it's truth valueless, then well, it is neither true nor false. So neither it nor its negation is going to be in the ersatz world that represents actuality. And therefore, by definition, we will have a case of metaphysical indeterminacy. But obviously, if there is indeterminacy that is not metaphysical, there is nothing wrong about the world there. It is just a semantic issue. It is a problem about the term Vulcan. Okay, so it seems that my view produces too many cases of metaphysical indeterminacy. Now, I'll give a reply, and there are two sub-cases. Now, consider the word-making language, which is the language in which we define the ersatz worlds. If Vulcan is an individual term of that language, and it is vacuous, then that language just cannot be the word-making language because we assumed that the word-making language is not semantically defective. So it does not contain empty terms, and it does not contain semantically indeterminate terms. Okay. Okay, this is the first case. But, okay, so let's assume that Vulcan is a term in the word-making language, and it does refer to something. Then the problem will be the following. The problem will be, how are we going to define the notion of truth at the world for a sentence like that? Okay. In particular, a sentence with an empty term. And now there are several options in the market. The obvious choice of logic for a language with empty terms is free logic. And free logic has three different kinds of semantics: positive, negative, and neutral. The positive says that an atomic sentence with an empty term may be true or false. A negative semantic says that that sentence will always be false and its negation true. And the neutral case says that any term, no matter its syntactical complexity, will be truth valueless. Okay. So in this second subcase, the problem raised by the objection, in fact, only arises if we adopt a neutral semantics for free logic. Okay. And now my theory is independent of that choice. So if the moral is that this objection is not an objection to my theory, it is an objection to the conjunction of my theory and a free logic with a neutral semantics. Okay. All right, so and now I'm going to start the last part of my talk, which is about the logic of semantic indeterminacy. What I'm not going to do is defend in 10 minutes?
A bit less, sorry.
Okay, I can. All right. I'm going to do it. Yeah. Well, again, I'm not going to defend any specific logic. I'm only going to make 2 points. Point 1, the logic is non-compositional. Point 2, the logic is non-classical. Why is it non-compositional? Let's take P and P prime, which again represents, say, all the possible states of our particle E. And suppose that E is in a superposition of positions. The following happens, that P or P prime, that disjunction, which is equivalent to E has a position, is going to be true. Okay, and we already saw why that is the case. Now, replace that P prime with P. What we get is P or P. Now, even if we don't know what the logic is, I assume that no matter what the logic is, it will have to make P or P equivalent with P, okay, which is indeterminate. So this disjunction is indeterminate, and this is true, and they only differ by the replacement of one formula, subformula, with a one which is has the same truth value, but the complex disjunctions don't have the same truth value, so the theory is not compositional. And this is interesting, and this is the last thing I'm going to say, because David Albert said the following thing about quantum superpositions. He said, the right way to think about superpositions of, say, being black and being white is to think of them as situations wherein color predicates cannot be applied, situations wherein color talk is unintelligible. Talking and inquiring about the color of an electron in such circumstances is like talking about whether the number 5 is a bachelor. And that's the way things are on this view for all sorts of superposition. Superpositions are situations wherein the superposed predicates just don't apply. Now, if I'm right, Albert is only partially right, because when a predicate is atomic, is simple, okay, then it doesn't apply. When a particle is in a superposition of positions, none of the predicates about positions can be applied to the particle insofar as that sentence, the resulting sentence, is not part of the relevant ersatz world. However, complex predicates, like being here or there, then they can apply because, say, the sentence, the particle is here or the particle is there, is true. Okay, so this is the last thing I'm going to say. I had another part about the non-classicality of this logic, but I'll skip it. So here are the conclusions. We saw that the Barson-Williams theory cannot model quantum indeterminacy. I propose a new theory, which is model but not precessificational. I argue that it doesn't have a problem of modeling quantum indeterminacy. I argue that it requires a revisionary ontology of ersatz worlds, and also that the logic of metaphysical indeterminacy is non-compositional. That's it. Thanks.
I am going to read my comment, not to lose too much time looking for the word, that my English is very elementary. I would like to restate very briefly the background of the discussion on some of the arguments in Torza's contribution, even if he has been very clear, and here and there to add some critical remarks. The problem we are facing is not whether there is metaphysical indeterminacy, but how we should understand this question. What is metaphysical indeterminacy? We have a better understanding of epistemic and semantic indeterminacy. For instance, everybody knows that Goldbach's conjecture says that an even number greater than 2 must be the sum of 2 primes numbers, and also that there is no proof of it until now. Suppose that there could not be a mathematical proof either of the conjecture of its negation. In that case, it must be true. It's interesting because if we can't know the truth value of Goldbach's conjecture, it must be true. But although we cannot know it, it would be a case of epistemic indeterminacy. We also have some examples of semantic indeterminacy. A very known example is that of the Indeterminacy of Translation. According to Quine, all the evidence relevant to elaborate a translation manual cannot decide among at least 2 equally good incompatible translation manuals. He says that there is no fact of the matter which decides the question, but he only means that nothing else is relevant to meaning than this sort of evidence. It is a metaphysical conclusion, but I think it is not about metaphysical indeterminacy in the sense relevant to our discussion. But what could metaphysical indeterminacy be? We only have some intuitions and a negative characterization. Metaphysical indeterminacy requires that there is a proposition that is neither true nor false, although such truth value gap should not be seen as epistemic or semantic. Could we do better than that? Barnes and Williams, among others, have recently given an account of metaphysical indeterminacy. Alessandro has explained it in detail. I take a very short formulation concerning our actual world. There is indeterminacy in reality in our world if there are 2 precisifications of it that are not definitely false. Where a precisification is a maximally consistent set of sentences, an ersatz word. Note that each precisification of reality is perfectly precise. This is not a reductive analysis, but it gives some tools to work with metaphysical indeterminacy. For instance, it allows us to state that the logic of metaphysical indeterminacy is classical. That is what Barnes and Williams say. But for Scout, this kind of indeterminacy is shallow, and he asks if there is a deep metaphysical indeterminacy according to which reality cannot be completely precisified. He thinks the kind of indeterminacy stated in Heisenberg's principle in quantum mechanics is a deep one. This phenomenon does not fit Barnes and Williams' model because if we take their proposals seriously, there will be 2 precisifications, as Alessandro has shown very well. One consistent, for instance, containing, for instance, M, the momentum, P, a position, another M, and another position P prime. But by Heisenberg's principle, there are not such possible ersatz words. For Scout, the challenge is to model deep metaphysical indeterminacy, and that's what Alessandro does in his paper. I will examine some of his arguments, but I shall begin with a distinction made many years ago by Ernest Sosa. In the epistemological discussion, there are 2 starting points. In the first one starts by asking what knowledge is, and then looks for something worth of this name. The second starts with the recognition of some science or theory as a paradigm of knowledge, and then the task is to explain how this knowledge is possible. We could ask what is metaphysical indeterminacy, and then whether, for instance, Heisenberg's principle fits this description. Alessandro does both things, but I divide in these 2 parts his argumentation. He argues Heisenberg's indeterminacy is metaphysical, and then he tries to describe it. For this part, I will avoid the more technical arguments. Well, the first question is whether we should take Heisenberg's indeterminacy as a counterexample to Barnes and Williams' proposal. And I ask first, what is the relation between, or what should be the relation between metaphysics and physics? If I got him right, Alessandro does not need to suppose that the thesis of indeterminacy associated with the orthodox interpretation of quantum mechanics is true, but only that it is possibly true. Let's grant this point for the sake of discussion and suppose that the possible world where this indeterminacy takes place is ours, only to make things easier. But is it really a case of metaphysical indeterminacy? Apparently, it is what the orthodox interpretation says. It is indeterminacy because it's indeterminacy whose source is not knowledge or language. Nonetheless, Alessandro addresses some interesting previous questions. One has to do with the consideration of quantum formalism as incomplete, but this is a very technical point. I will concentrate only in the second. Consider his example. An electron E whose momentum is determinate but has no determinate position. According to Barnes and Williams' model, given that no P and no P prime are both in any ersatz world, we might describe the case as E is definitely not in any position. In that case, this would not be a case of indeterminacy. It is definitely not in any position. Alessandro replies that cannot be so because this electron might be at a determinate distance from another particle. As he says, being at a distance of something from something presupposed to have a position. I am not convinced that we should accept this presupposition. First, I take a bad example. Suppose the particle is indefinitely in the circumference of a circle, although at a definite distance from the center. Examples like this were common in classical calculus before the 20th century. Let me give another example that might be more relevant to the further discussion. Let's take some of the classical examples Brouwer offers to prove the invalidity of tertium non datur. For him, the continuum is built of choice successions. Each succession is given by an initial segment of decimals, and a rule such that given an initial segment of decimals determines a range of possible selections for the next decimal. Or, for instance, the next number in the succession could depend on whether a mathematical problem has been solved at a given time. I can say, for instance, I can think Brouwer's example. Normally he takes, for instance, a real number, and a succession that is oscillating each time closer to this point. But if a mathematical problem is solved in time n, then we stop. If not, we follow. This is the case. The succession can oscillate left and right of a positive number m, getting ever closer than it, and will stop at a particular rational distance of m when this problem is solved. If not, it converges to this number. This process generates a real number. It is indeterminate if this number is greater, equal, or less than m. But it can definitely be greater than 0, for instance. For me, it illustrates the point that to have a distance of a point does not imply having a definite position, or a position. I should state a position. In such case, in quantum mechanics, distance must be regarded also as indeterminate. Alessandro considers other unsuccessful attempts to save Bernard's and Williams' proposal. Barnes and Williams' proposal. For example, one, to take two ersatz words that not exist if there is indeterminacy according to Barnes and Williams, as physically impossible but metaphysically possible, or to take seriously impossible words. I think these are very exotic solutions. He concludes that if quantum indeterminacy is metaphysical in character, then ersatz words should be consistent but possibly incomplete sets of sentences. And proposes the following characterization. A word is metaphysically indeterminate when it is adequately represented by an incomplete, consistent ersatz word. His proposal is that for each word, possible word, well, real in the sense that not ersatz, there is exactly one ersatz word, and a word is indeterminate if its corresponding ersatz word is incomplete. I think Alessandro's is a good answer to Scout challenge, even if it is given in terms of precisifications, because Scout thinks, okay, I almost finished. Of course, it is not plugged with the circularity present in Barnes and Williams' characterization, but I think it does not offer us a better understanding of indeterminacy beyond what quantum mechanics says. I think Axel talked a little bit more.
Well, 15 minutes, right?
Okay, or 20.
Yeah, tough life.
Then I repeat. But I think it does not offer a better understanding of the indeterminacy beyond what quantum mechanics says. In particular, does not tell anything about the source of the nature of this indeterminacy. For instance, a theory of epistemic indeterminacy should provide not only a description, as also an explanation of it in terms of epistemic concepts. To illustrate this, I shall take again Brouwer's example. When the determination of the number depends on the future solution of an unsolved question, we might interpret this epistemologically, but we might interpret it metaphysically also, and take the indeterminacy as being part of the nature of the number. What is the source of this indeterminacy? The intentional nature of number. The manner a number is determined is part of its essence. I think this was Brouwer's idea. Maybe we could say something similar for quantum mechanics. The indeterminacy emerges in the interaction between subject and object, even if it is not purely epistemological. I think an analysis of a notion should give us a better or deeper understanding of it. What is the logic of metaphysical indeterminacy? Albert's, I do not need to repeat. Alessandro's has just finished to explain Albert's idea, but his observation against Albert is the next example. A particle has a position in virtue of being a determinate distance from another particle, but non-specific, not in any specific position. In cases like this, the existential quantifier is not be the classic, and we need, of course, a different logic. Although I will come this logic, because it's very interesting, The example does not strike me as valid, as I have said before. And the last thing, with the idea of completeness, an ersatz word as a maximally consistent set of sentences, we have knowledge of the range or the domain of all possible words. We have a very abstract, but a complete knowledge of the range of all possible words. I think with Alessandro's proposal, we lost this a priori knowledge. And among other things, because we do not know now what consistency is, because we don't know what is the logic we should take to define ersatz words. Thank you very much.
Thank you. All right, so I'll briefly reply. You touched upon a lot of points. Of course, I don't have time to go through all of them. I'll start from the last one you mentioned, which is something that I would have said if I hadn't skipped the last one or two slides. You say that we no longer, I mean, given my account of a logical space as comprising incomplete ersatz worlds, we no longer have an a priori knowledge of the nature of logical space. Mm-hmm. And I think that is not a bug. It's not a bug, but a feature. I think that the problem of of the logic of metaphysical indeterminacy is a posteriori issue. Mm-hmm. It's not something we can solve from the armchair. So we should study specific cases of metaphysical indeterminacy and trying to see what the logic governing these cases is. My very tentative hypothesis is that the logic is not stronger than quantum logic. And the reason is that given all I've said, conjunction does not distribute over disjunction. This is a point that has been made classically, although my reasons are somewhat different from the classical one. But since quantum logic is, in fact, a logic in which distribution fails, my conjecture is that the logic of quantum indeterminacy is either quantum logic or something weaker than that. All right.
May I make a small observation? But if you take, for instance, Albert's idea, then your example is not valid. The example of the distribution of the non-validity of conjunction over disjunction cannot be taken as valid if Albert is right. Then it depends on how do you describe this same phenomenon. It's not only...
I mean, again, Albert believes that position predicates in general don't apply to a particle in a superposition of positions. However, that's true only if we assume that the logic is compositional. And I've argued that it's not. Okay, I might be wrong about that, but again, I have my doubts about the general point that Albert makes. Another point that you made is about, so I had this argument in which I argue that a particle can have a distance, can have a position even if it is in a superposition of positions. And my argument was that a particle can have a determinate distance from something, and if you have a determinate distance from something, then you must have a position. And you argued against that, and you gave the example of the
circumference.
Yeah. Can you repeat that? Because I'm not sure I understood that example.
I can suppose that the particle is the position is indefinitely
Yeah.
in a circle, because, for instance, I think it's moving
Yeah.
in the circumference of a circle, and it has a definite distance of the from the center.
Perfect.
But it does not mean that have a position, that it has a position.
It's moving, isn't it, just in different positions at different times?
We could say that, but this
I mean,
is not.
I just don't see your argument. I mean, I understand the example, but I don't see your argument for why this particle would not have a position. I mean, again, I had an argument for my thesis, so I assume that perhaps one of my premises is false, and I'm not sure which one would be false in this case.
But what I was arguing, that it has distance and position cannot be understood with these words with the same meaning or sense as ordinarily. We are in a very, very strange theory where we can say not that the point is moving around the circle, but that we have a probability only that.
Of the position.
But
that's perfectly consistent with what I said. I mean, all you were saying is that the particle does not have a determinate position, and I agree with that. Okay, a different point is saying that it does not have a position, and this example doesn't show that.
But of course.
Last one. I mean, you can. I need to move to the Q&A.
Okay. Yes, I shouldn't say that it has a position. Not only a determinate position, but a position. I think it's a thing of how do you describe this phenomenon? But Bob.
All right.
All right. So questions, please keep your hands up. All right.
Oh, it's a very interesting paper. I like the issue of indeterminacy. I have a couple of questions. One about the earlier argument involving Heisenberg, because part of the issue there is how to interpret what exactly is the indeterminacy. If you consider the 1927 paper that Heisenberg did, it was very clear that he was concerned with an epistemic issue, right? We cannot measure the position and the momentum with full certainty. But that has nothing to do with the metaphysics. In fact, Bohr complained bitterly against him and said, no, it's part of the nature of the quantum world to be complementary.
Yeah.
So he thought that there was indeed something going on. But that was not the way that Bohr ran the argument. So part of the issue is how far can you get, or how much can you get in talk of indeterminacy at a metaphysical level from quantum mechanics. Right? So it really depends on your interpretation of quantum theory. But then the examples gets a little more complicated, because depending on how the interpretation you're going to offer, you're going to actually get very different answers. So I'm a little concerned about that part of the argument. Right? Now, on the positive side, I'm concerned about thinking about worlds in which you have incomplete. Earth at work when you have incomplete bits of information as worlds at all. Right? At least are worlds that can genuinely be taken to be worlds of reality. Right? Because I think the hallmark of fiction is that you can have incompleteness, right? There's no fact of the matter as to what the color of Sherlock Holmes' left sock when he solved the Moriarty case, right? And that's fine, because it's a fictional world. Lots of things that are unsettled, and it doesn't matter. Now, since you're interested in talking about metaphysical indeterminacy, it's hard to me to square that with the move towards incompleteness. It looks to me as though you're then just talking about fiction, not about real world. The world as we know it is entirely determinate, right? In that sense.
All right, thanks. Great question. So about the first one, you're perfectly right that whether there is metaphysical indeterminacy at all depends on which interpretation of quantum mechanics we're buying. But I'm not really making any assumption on that. I mean, this is really Scout's argument, it's not mine. And it says that all we need to assume is that the orthodox interpretation, which takes quantum mechanics as complete, is at least possible. So there is at least one possible world in which the Barnes and Williams characterization doesn't work. Okay, if say Bohmian mechanics is true in actuality, then we don't even have indeterminacy at all. All right. About the second point, all right, that's very interesting. So
can I just say one thing about that?
Okay, sure, go ahead.
Because I think, yeah, it's addressed against Scout, but then the argument that he has won't go through. Because if it's presented in terms of, look, quantum mechanics gives us the indeterminacy, and you invoke that as a fact in order to undermine the characterization that Williams and Barnes provide, then the argument won't work. Right? So you really need to take a stand and say, okay, look, this is the way the world is, and there is no way of making that claim, right? Given what we know about the foundations of quantum mechanics. All of those Bohmian interpretations, Copenhagen interpretations, many worlds interpreted very different pictures about what's going on regarding determinacy or not, are all empirically adequate. There's no way we can tell which of them is the right one.
Yeah.
Right? Now if you say, look, that's only the sheer possibility, it's enough to make the point, then the question is whether you're really talking about a possibility about reality. It then depends on which of those interpretations, not only it's possible, which of them is true, and that we cannot settle.
I'm not sure I can put a finger on where your worry is, because I agree with most of what you say.
Okay.
Of course, there are a lot of interpretation of quantum mechanics, and in some of them there is no indeterminacy, and so for theory there is no deep indeterminacy. But I take each of these interpretations to be consistent. If they're consistent, they're true in some world. So one of these is the orthodox interpretation. It is usually regarded as an interpretation by which quantum mechanics is complete.
Right. Okay. I'll see one thing and I'll shut up.
So even if the indeterminacy is not about this world, okay, it is about some world. And so since Barnes and Williams theory is supposed to work not contingently but necessarily, so it will fail.
Yeah, but that presupposes a conception of worlds, in which worlds are spatial-temporal maximums, spatial-temporal things. And that also has a problem squaring with some features about quantum mechanics, right? So it's not so simple to say, oh, look, this is consistent, so there is a world in which this is true. Right? Because part of the problem is what kind of space-time do you have underlying quantum mechanics? And that also is an issue about interpretation. Can you formulate quantum mechanics without spatial-temporal notions? Right? Oh, yeah, there are interpretations like that. Right? Not the regular ones, but they're applicable as well. So things are far more complicated than it's been suggested by that line of argument. So I think the use of modality in the context of quantum mechanics has to be taken with a lot of care, because a lot of off-the-shelf metaphysical views just don't square around, right, when we consider those theories.
Yeah.
Okay.
I mean, I'm aware that the debate about the nature of quantum mechanics is very vexed and complicated. I was just assuming, a somewhat standard view about what the positions are in the debate and what each position says. But yeah, I'm aware that there are other issues. Now, okay, your second point was about fiction, and when you say, for instance, if we say I don't know. Sherlock Holmes did this and that on day X, okay? And that is indeterminate because, well, the story doesn't specify whether Sherlock Holmes does or doesn't do such a thing. Now, Well, I would say that these are not truth about our world. So it is just false that such things happen. So, yeah, so, okay. What I would say is that all these truths are actually, I mean, these are truths in fiction. They're not truth simpliciter, okay? So, if we say Sherlock Holmes did this and that, my reaction would be, well, that's false, okay, in reality, and true or indeterminate in the fiction. So if we're interested about cases of indeterminacy, we should look at the fiction, right? So what is true in the fiction rather than what is true simpliciter. And if in the fiction there is a gap, there is a case of indeterminacy, then I would say that that is an instance of metaphysical indeterminacy about the world described by the fiction, okay, but not about our world. So I would be perfectly okay with calling that a case of metaphysical indeterminacy as long as the relevant world is not ours, but the world of the fiction. Yeah.
Aldo, do you want to make your question a follow-up to this one, or you have?
No, okay, I can wait.
Okay. Seth?
Okay, I wanted to note like one kind of connection, I think, between what you're doing and some other stuff, and then maybe suggest a possible application.
Yeah.
So I really like the story. It reminds me of this paper by Humberstone, From Worlds to Possibilities.
Mm-hmm.
So where he develops this modal analog version of temporal logic. So that basically he starts with that picture of, we have this familiar picture of logical space, set of possible worlds as the points of the space. But instead, now let's think of the possibilities as regions of the space. And this is sort of like inspired by temporal logics that need to talk about intervals of time. So just like we might talk about intervals of time, we can think of possibilities as what basically like sets of points. So sets of possible worlds in the old sense. And then he shows how to give a normal modal logic taking these over these entities, basically. So just kind of starting from our old picture, set of space of possible world, metaphysical possible worlds, and then just treat the possibilities as the power set or the subsets of the domains. Strictly speaking, you don't really need the space to even be points. You could have something more gunky, and you could think of possibilities as regions of the space. So that's a picture of possibility that you could have, and that Humberstone worked out, and it reminds me a lot of the picture you're describing, because possibilities are basically, they're basically not fully specific. So, you have the same kind of indeterminacy. You don't have to talk about ersatz worlds. So, I'm wondering where exactly ersatz worlds come in your picture. Like, maybe you could help me understand how your picture differs from a picture like the one I just described, which is the sort of thing Humberstone sketched, and people like my colleague Wes Holliday are working on the logic of this kind of framework and like just redoing modal logic in this kind of possibility semantic term. So possibility is the word Humberstone used for, the name of the paper is From Worlds to Possibilities, and he was suggesting we move to thinking of, evaluating truth relative to these indeterminate regions of logical space. So, I mean, is that in the spirit of the kind of view that you prefer? I mean, the main difference I noted was the role ersatz worlds played, and you were arguing, well, ersatz worlds don't have to be complete, right? But why do we even need to talk about ersatz worlds? Can we just talk about
worlds?
Yeah.
So let's see if I understood the kind of framework you had in mind. So you're thinking of a situation in which if M is true, but P is indeterminate, then we're taking the set of worlds where M is true.
Right.
And P is either true or false.
That's right. Yes.
Yeah.
And now we're going to regard that as like a possibility itself.
Yeah, and yeah,
as it were.
yeah.
Don't strictly think of it as.
So basically, what is usually called the proposition, you're now
Yes.
calling a world.
That's right.
Or a Nersatz world.
Exactly.
Yeah, actually, that was the first formulation
Oh.
of this theory.
Okay.
But I decided that I would stick to a more conservative approach, insofar as the original Parsing-Williams theory
Right.
is defined by means of words and Ersatz world. So I would just want to make the minimal divergence from their view, which I thought would be easier to understand for readers who already know the
Gotcha.
theory. Yeah.
Okay, and then the application I was going to suggest to maybe, because this question's coming up, like, well, what anyway is indeterminacy? I get the model, but like, help me get into the mood for this picture of reality. And then these sort of quantum indeterminacies are sort of classic examples of, well, maybe that's what a paradigm instance. Another kind of case you might reach for are these like debates in metaphysics about between so-called absolutist and relationist views. I wonder if you might be interested in applying this kind of apparatus to that. So this is something I'm interested in. So, you might be a relationist about space, and you might think, spatial relations are, and those just are relations between things in space. They're not explained as, well, you put things in space, and then spatial relations between objects are just parasitic on the relations between their spatial positions. Or you might be, you might think, you might be a relationist about orientation. Like you might think, well, in a certain objective sense, if you were to sort of mirror reverse all of reality, that wouldn't actually be a different possibility. That would just be this world sort of redescribed. I mean, all these kinds of views where you have what's called Leibniz equivalence, like you sort of consider this world has moved that way 3 feet. People say, no, that's not a different possibility. That's you're just redescribing reality. So you can imagine views which say, no, you can distinguish 2 positions. So what I'm thinking is you might be able to use some of your apparatus to like describe these debates. So you might say, what the relationist is saying is that reality is characterizable as less determinate than the absolutist about the relevant domain of property. So if I'm like a relationist about orientation and I think, well, there's really no leftness per se to my hand. There's relations of congruence between objects, but there's no sort of like intrinsic representation, intrinsic orientational feature. Then I can be contrasted with the absolutist who does hold that. The absolutist is holding like, well, actuality is more specific. Like actuality settles these facts that the relationist thinks, no, reality is less specific than that. There's less structure. And you can imagine this view like a less structured kind of view about all sorts of things, the direction of time and all sorts of spatial properties. So another kind of application maybe with this sort of picture is to characterize these debates in metaphysics between relationists and absolutists. I think relationist is the one who's holding reality is less specific, and we can model that by saying less complete or indeterminate, maybe.
Right. So, okay, so, I mean, the cases you have in mind are, I guess, the standard cases of Hexietism. So the issue is whether the non-qualitative features of the world supervene upon the qualitative ones.
Well, you might think if you're an absolutist about, like, space.
I mean, if you think that moving space by 10 meters to the right, and if that's a different possibility, then you're thinking that the non-qualitative features of reality don't supervene upon the qualitative ones. Insofar as qualitatively the 2 situations are exactly the same, but there is some difference with respect to non-qualitative features, such as I'm here or I'm there, right?
Yeah, well, I mean, maybe that. that case, it's tricky because there's different ways of being an absolutist about space, and it depends what you want to say. But so I don't know that the problem, the kind of distinction I was proposing really reduces. Hexaid could be an application, actually, so I won't agree with that. But I'm not sure I'm thinking of the absolutist as necessarily hexaidist. It's just a kind of theorist that goes in for more structure to reality. I'm not sure the structure has to be non-qualitative. I mean, if you just think space is real, it still will be qualitatively described. It's just there's more stuff in reality, namely space and space.
Yeah. Well, anyway, yeah. Well, your question is whether we can model it as a case of metaphysical.
Yeah, I'm wondering just what you think about that. Like, what if?
Yeah.
It's just be another kind of. It helps to get a handle on. If it all turns on how we understand quantum mechanics, that's a little bit of a bummer.
Mm-hmm.
Since that's such a vexed issue, I wonder, like, if there was this more general application, I feel like I get a sort of better grip on. Oh, okay. This idea of metaphysical indeterminacy, not that crazy actually. Most people who most philosophers of physics are relationists about orientation, but maybe on this understanding, then they think reality is indeterminate in a certain sense. There's a way it could be more, there's a logically possible way it could be more specific, there could be more structure. And just as a matter of fact, we discovered that's a symmetry of space-time, so there isn't such structure.
Yeah, I mean, actually, I haven't thought at all about that, but that could be, I think, an interesting application insofar as my notion of metaphysical indeterminacy boils down to a fact of the matter view about what is the case, and one might say that in these cases that to me sound a lot like hexaidism, and then there is no fact of the matter as to whether the world is it has an orientation, absolutely. Yeah, but I should think more about it in details. Prima facie, it sounds like a possible application. Yeah.
Jeff? So I might have missed something, but I was wondering whether the following way of understanding your view was correct. Not that it's bad if it is correct, but I just wanted to know this seems something. So these Aristotle's worlds are like, long conjunctions where the vocabulary in sentences is restricted in a certain way, right? So let's call a sentence that can be part of one of these Aristotle's worlds an e-sentence.
Can be.
Just call, so let's say an e-sentence is the kind of sentence that can be a part of one of these Aristotle's worlds.
Yeah.
The restrictions are. So then, is your view equivalent to the view that W exhibits worldly indeterminacy just in case there's some e-sentence such that neither it nor its negation is true of W?
If by e-sentence you mean
The kind of sentence that can be in
a conjunction of all the sentences in a standard Aristotle's world.
An e-sentence is the kind of sentence that can be a conjunct of an Aristotle's world.
So what I'm saying is that there is metaphysical indeterminacy in case the conjunction of P, P prime, etc., such that every sentence or its negation is in there is neither true nor false.
Okay, I'll think about it. Thanks.
But I mean, I'm not sure if I understood your proposal, but I mean, in general, there is metaphysical indeterminacy when there is incompleteness. So there is at least one sentence which is such that neither it or its negation is in the set.
So, okay, but that's what I was thinking.
Okay.
So I'm wondering if that just places a lot of weight on the definition of the class of e-sentences, the class of the relevant sentences. Because it just sounds a lot like the view that we have metaphysical indeterminacy just in case we have truth value gaps that aren't due to semantic defects.
Yeah.
Is that, okay.
Yes.
We're on the same page now. Thanks.
exactly.
No, it's exactly the same question, same word. But I want to add then a little clarifying question. Why is does your formulation uses true instead of determinate true? Your definition
Of adequate?
Yeah.
That's right.
why is it considered true instead of determinate true?
I'm just not assuming that determinacy in our primitive language. Yeah.
Okay, so one of the works I have is related with this first observation regarding the scope when you want to account for this notion of Metaphysical Indeterminacy. And this thing of trying to account for this notion and imagine that the Copenhagen interpretation, we have to suppose that there is a possible world in which the Copenhagen interpretation is true, and to what extent this matters or not. I was thinking that maybe if his worry was that maybe Bohmian mechanics turns out to be true, then we shouldn't worry about that. But then I understand that we may want to have an account as wide as possible for this notion or for other non-metaphysical notions such as causation. We encounter the same worries. But then I was thinking, okay, imagine Bohmian mechanics is true. It sounds odd to me that we have to worry about the Copenhagen interpretation. It seems also that we should worry then to account for the notion in a possible world in which Aristotelian physics is true. We should also try to account for the notion in fictional worlds in which odd laws of nature hold. So this is just adding the same that he was more or less raising. But then let me add something more specific. That is that, okay, regardless of that methodological issue, I don't see, I've never seen very clear. You follow this strategy, but then coming to some specific point in your account when you try to reply an objection in which you have two unsharp values. Okay, you have a reply in order to account for this in your theory. You stick, your argument relies on some fact about quantum mechanics. So you are trying to make an account very wide, but then in order to resolve that objection, you are sticking to some fact about quantum mechanics. You know what I don't.
Well, if I understand what you're referring to, the fact I'm supposing is that every state is an eigenstate of some operator.
Yeah, exactly. So, can you tell me if this might be a problem? The fact that you are trying to account for this notion as wide as possible in all metaphysical possible worlds, but then in order to reply that objection, you are sticking to some specific fact about quantum theory. You know what I mean?
Yeah. So is there any interpretation of quantum mechanics in which that is false?
Well, that thing was, I know
that
there is always
that every state is an eigenstate of some operator.
Well, the interesting thing is that even if there is no interpretation of quantum mechanics in which this is false, somebody could tell you, okay, I don't care. There might be a metaphysically possible world in which this is false, just because of the thing we were raising now of the scope of the account.
Well, the important issue is whether it is a world where quantum mechanics is true or not, because that the objection was specifically about quantum mechanics. Yeah. So if there is a world in which that is not the case, then
But I have the doubt that even if it is not considered by scientists, there is this metaphysically possible world in which we can say whatever we want, and that reply just it's not true. That fact.
Yeah. So that would be a world in which there is a state, but there is no property such that the particle has a determinate value there. Okay, that would be a problem. The issue is that the premise is a quantum mechanical premise. So the premise of the objection. So the premise is that there are multiple states where both position and momentum are unsharp. So, I mean, we are assuming the truth of quantum mechanics in order to set up the objection. Yeah.
I have a question.
Okay.
So it seems important to your view that you understand metaphysical indeterminacy in terms of a unique, incomplete world. And I was wondering if you can get away with that if you try to model other kinds of indeterminacy like metaphysical vagueness. I myself not sure whether there is such a thing, but some people believe that Kilimanjaro, for example, it's vague and that there's no fact of the matter about where it begins, where it ends. And then I was thinking, well, if you want to use incomplete worlds to understand that kind of indeterminacy, it's not at all clear that you can say that there is just one unique incomplete world, because you may get into lots of trouble with higher order vagueness. So in my paper about semantic vagueness, I make the point that there's no unique incomplete semantic model. Rather, there's a bunch of suboptimal ones, and that's the way I can get around higher order vagueness problems. So sorry for the question, it's a bit nebulous, but I wonder if you have some thoughts about that.
Yeah, I mean, about the Kilimanjaro case, it seems to me a case of semantic indeterminacy.
For me too, but the question was, let's suppose there is such a thing as semantic indeterminacy, vagueness, metaphysical vagueness. Do you think you can get away with saying that can be represented as a unique, incomplete possible world?
I mean, completeness is with respect to sentences,
Yes.
right?
Yes.
So, which one would be a sentence which
this rock is part of Kilimanjaro.
this rock is part of Kilimanjaro? Okay. I mean, I have a very hard time imagining this as a case of metaphysical indeterminacy, but if it had to be, then I would bite the bullet and say that, yeah, that sentence is neither true nor false. And so it doesn't belong to the ersatz world, relevant to actuality. Yeah.
Okay, fair.
Maybe this is relevant to what you just asked. So how much indeterminacy can we have and still have a possibility on your theory? Like, could we just have a possibility where
Nothing.
there's a dog, there's just no fact about how heavy it is, what color it is, how long its tail, like anything about anything specific.
Yeah.
It's just a reality that consists of a dog.
Yeah.
So is that's a possibility on your view.
Yeah, I mean, what I've said is about the nature of logical space is compatible with the existence of an empty ersatz world. Okay.
Yeah.
So
you think we should
however, also there is the issue of what is the logic of metaphysical indeterminacy. So every ersatz world will have to be closed under whatever logic is the correct logic. Okay. So assuming that the class of logical truths is non-empty, there will have to be some set of logical truths in these worlds.
Right.
Okay, and therefore there's not going to be an empty ersatz world. Which one is the correct logic, again, I think is an a posteriori issue. If it is quantum logic, as I conjectured, then every quantum logical truth is going to be in every ersatz world, and so that will end up being part of the description of every world.
Okay. I guess I was thinking, Well, one question is what the logical truths are, but another you might think there are purely metaphysical constraints to be investigated. So, you know, you might, like, again, if you have this picture of logical space, you might think metaphysical possibility corresponds, now that we're indeterminists, we allow that, well, the possibilities aren't necessarily the points of the space, maybe they're larger, or, you know, regions of the space. You might think metaphysical possibility is something like a partition of the space. So not every region corresponds to a real metaphysical possibility, although you can identify them logically, like maybe you could call them logical possibilities. But maybe there's a privileged notion of metaphysical possibility that would require something more, you know, in certain kinds of indeterminacy are okay, others aren't. I don't know if this is a legitimate notion, but it seems clear. Just because, you know, on the face of it, it seems a bit surprising to say that it's metaphysically possible that, you know, there's just a dog or whatever.
There is just a dog.
Well, like there are these possibilities that are so, you know, there's these high-level truths, and yet there's no specific way it's true, you know. Like, I'm perfectly happy with the idea of calling that like a logical possibility and having that object play a role in the formal theory. That seems totally unassailable. It's just more, it seems like we could ask, well, but is that metaphysically possible? Like, could that have been actual? Like, you know, there's a sense in which we might say, well, maybe not, even though that's a possibility in our theory in a certain logical sense, maybe it's not a metaphysical possibility.
Yeah, I mean, I see your worry as, is it possible there is some general fact which is true, but no specific fact?
Sure, yeah. Concrete cases, it can sound a little bit.
Yeah, it could be that there is a color, but no specific color.
Yeah.
Yeah, I think so. And in fact, actually, this is the notion of metaphysical indeterminacy that has been suggested by Jessica Wilson, and she defined metaphysical indeterminacy exactly in that way, as the fact that there is some general truth without some specific truth. Yeah.
All right, we're out of time, so let's take our